Today we're cracking open systemd path units, the reactive trigger that fires a service the instant a file or directory changes state. No polling, no cron loops, just pure event-driven activation powered by the Linux kernel. Systemd runs the show through unit files, declarative configs that describe every resource on the system. Each unit wears a suffix that declares its type. .service files launch daemons, .timer files replace cron with scheduled activations, .socket files wake services on incoming connections, .mount files handle file system mounts, .target files group units into system states, and .path files. Our focus today: activate a service whenever a file system path changes. A path unit and a service unit form a partnership. The path unit stands sentinel over a file system location. The moment something changes there, it shouts and the matching service unit leaps into action. They link together by name. foo.path automatically activates foo.service. Strip the suffix, and systemd knows exactly which two pieces belong together. Path units come armed with 5 core directives. PathExists equals fires once when a path comes into existence. PathExists glob equals matches a glob pattern. PathChanged equals triggers when a file's modification timestamp ticks over. PathModified equals goes deeper. It fires when the actual file data or timestamp changes. And DirectoryNotEmpty equals springs to life the moment a directory gains its first contents. Under the hood, systemd path talks directly to the Linux kernel's inotify subsystem. Inotify delivers event-driven notifications. -create when a file appears, -delete when it vanishes, -modify when its contents change, -moved_to when something lands at the watched path. No polling loops, no wasted CPU cycles. The kernel pings systemd the instant an event happens, making activation instantaneous. Here's the full lifecycle. Systemd loads the path unit, registers inotify watches on every configured path, then waits. The moment a matching inotify event lands, after a small stabilization delay, systemd triggers the path unit, which starts the matching service unit, then settles back into watch mode, ready for the next event. It's a tight loop. Path event flows into the path unit, the path unit hands off to the service unit, and the service unit does the real work. Systemd's path units watch files or directories and trigger actions when they change. Inspecting them is straightforward. A few targeted commands reveal what's installed locally, what ships with the distro, and how path units differ from their sibling timer units. First, we clear the screen to get a clean workspace, then confirm which version of systemd we're working with. The head -1 pipe grabs just the first line of the version banner. Fast and unambiguous. Next, we look at locally installed path units. Anything you create in /etc/systemd/system overrides the distro defaults, so this directory is where your custom path units live, assuming any exist. To contrast path units with their closely related sibling, we inspect systemd-tmpfiles-clean.timer. Timers fire on a calendar or monotonic schedule, while path units fire on file system change, different triggers, similar mechanism. Finally, we list every path unit that ships with the distribution itself. The /usr/lib/systemd/system directory holds the vendor-provided units, and the grep filter narrows the listing down to just the .path files.